Hi, welcome to Molecular Geometry Magic Kit Learning Center. I'm Madam Chu. I'm going to guide you through the learning process of SP3D2 hybridization, which involves octahedral arrangement. Let's begin. SP3D2 hybridization involves 6 hybrid orbitals. Let's count 1 s orbital, 3 p orbitals, and 2 d orbitals. So altogether, you have 6 hybrid orbitals. So this kind of hybridization only occur with the elements which is quantum shells 3 and above. Because quantum shell number 1 and number 2, they don't have d orbitals. So the 6 hybrid orbitals will arrange in octahedral shape, which the bond angles are all 90 degrees to one another. So look at your model. You are going to identify or search for the screw with numbering 6. You will eventually get one white screw out, one green screw down, one silver screw with gold labeling, and 3 silver screws. Are you ready? Let's explore ourselves. Introduction. About hybrid atomic orbitals, hybridization is the process of mixing together 2 or more atomic orbitals that have similar energies. There are 5 important types of hybrid orbitals such as sp3, sp2, sp, and sp3d hybrid orbitals, where we are going to learn more about sp3d2 hybridization in octahedral arrangement. In general, the number of hybrid orbitals equals to the total number of atomic orbitals involved in bonding, especially the sigma bond. So we are going to use sulfur hexafluoride as example. So in sulfur hexafluoride, identify the center atom, which is sulfur. So the ground state electronic configuration of sulfur, you have 6 valence electron, right? So you're going to arrange like 3s2, 3p4. So in this case, the maximum number of bonding formed is 2. So how to produce sulfur hexafluoride means 6 fluorine atom bond to it. So you have to excite the electron to the higher energy level, the orbital of the higher energy level. So this electron excited to 3D orbitals, and this electron excited to 3D orbitals. So all the orbitals over here are from different shape and different energy. However, all of the 6 orbitals here is going to undergo hybridization. Then after hybridize, you are going to form 6 sp3d2 orbitals, which have similar shape and energies. So you look at it, they are all the same already, right? So 6 sp3d2 hybrid orbitals. So these 6 sp3d2 hybrid orbitals are going to arrange in 90 degree. So if you look at this stick and bowl, it look clearer, right? So 90 degree, up and down 90 degrees. So all 90 degree with one another. So are you ready? Let's scan the QR code to explore it ourselves. Sulfur as a center atom has 6 valence electrons. The 6 valence electrons undergo excited state and hybridization. The orbitals undergo hybridization, eventually will produce sp3d2 hybridization. And all the hybrid orbitals will arrange in octahedral shape, which is 90 degree to one another. So look for the 1 white, 1 green up and down, and the 4 silver screw, which one of it is golden labeling. Right, so can you do it? Up, down, or 90 degree? How is your experience on building the octahedral molecular shape using the model? Do you find all the bonding here 90 degree? Yes. Alright, let's further our learning to higher level, where there are other examples of the sp3d2 hybridization, such as this is a complex ions. You see the ions. This is hexachloro stannate 4. So tin come from group 14. So if it is negative ion, you are going to name as standard. So in this case, it is octahedral because all of them are having the bonding pairs. So you see, this is octahedral shape, 90 degrees with one another. Now, why the boron pentafluoride and xenon tetrafluoride looks different from the octahedral shape over here? Can somebody give me the answer? Yes, it is due to the presence of lone pairs of electrons. Yeah, bromine as a center atom, it has 7 valence electrons. So in order to bond with 5 fluorine atom, you are going to use the 5 electron in bonding pair. 7 minus 5, you have 2 electrons left. So these 2 electrons will be exist as lone pair of electron. Lone pair of electron exists inside the atom. So now the molecular shape is a square out. So this is known as square pyramid. Yeah, over here is a square and out. You cannot see the lone pairs of electrons. So according to valence shell electron pairs repulsion rules, where the lone pairs of electron occupy greater space, we said lone pair, bond pair has greater repulsive forces than bond pair, bond pair. In this case, all of the bond anchor are 90 degrees. So you can only choose one. Either you choose the side over here, eventually you will get to the same shape, which is square pyramid. Try it out. You just screw one of the bonding into the bone. So what is the shape you get? Is it square pyramid? Right. So let's try out. Now, when you choose the second lone pair of electron, now you cannot choose the side because the side where all the bonding here are 90 degrees. However, the other side is 180 degrees. So according to valence shell electron pair repulsion forces, the lone pair has greater repulsive forces than lone pair, bond pair, and it is greater than bond pair, bond pair. So the 2 lone pair of electrons will choose the opposite direction, which is 180 degrees, and eventually your molecular shape now looks like what? Square planar. Try out. So if you screw one screw is screwed in after you build the boron pentafluoride, right? So you have to screw in the opposite direction, 180 degrees, because they occupy the largest space, right? So can you get square planar? Yes, very good. Thank you.